Hello everyone, my name is Sudha Agarwal and welcome to my channel 4K Solutions. In today's session, we are going to see destructuring and REST. Then we'll see classes, interface and arrow function. Now we are going to see what is destructuring and REST operator. Through destructuring, we can extract values from objects and store it in variables. It is a way of extracting values into variables from data stored in objects and arrays. There are three types of destructuring: object destructuring, array, and functional parameter destructuring. So let's see what's an object destructuring. Suppose we have an object like this, an object with three properties: fname, lname, and age. Suppose we want to extract the value of this property and assign it to a variable. So how would we write? We write like this: constant f equal to obj.fname. And to extract the second property value, we'll write like this: constant L equal to obj.lname. So prior to ES6, we have to write like this to extract the values of this object. But with destructuring, we can write the above code like this. We can write it like this: const fname colon f lname L equal to object. So what it will do is that it will extract the value of this property fname and assign to the variable f, and it will extract the value of the property lname and assign to the variable L. Okay, so we'll print it out, or we can write the code like this: for fname colon fname lname colon fname. So if we can have the property name and the local variable name as same, we can have the local variable name as same as the property name, and variable property name and the local variable name, they are same. We can write it like this: fname lname equal to obj. So what it will do, it will extract the property value fname and assign to the local variable fname, and it will extract the value of the property lname and assign to the local variable lname. So we'll see how we can do the object destructuring. So let's create a new file. We name it as destructuring ts. Now let's create an object. Oops. Yeah, that's fine. As we know, we can assign the values of this object to individual variables like this. But with destructuring, we can write it like this. We can write it like this. So it will assign the values of this ABC to F, XYZ to L variable. But with TypeScript, we have TypeScript is strongly typed, so we generally provide the data type of that variable also. So we want to write it like this. In TypeScript, we provide the type also. So this won't work with TypeScript, because what it is doing is it is assigning the value of this property fname to the variable named string, and again it is assigning the value of this property lname to the variable called string. So what we do is that so it won't work. So the correct syntax is So this is the correct syntax. It will assign the values of this object into the variable fname and lname. Or we can have a better way. We can use interface also. So instead of writing like this, we can use interface also. So we'll write like this, interface. And write it like this. So we can write the above code, this code like this. So we'll create an interface of, we'll specify the type of these two variables, and then we'll can write it like this, constant person p equal to obj. So this is object destructuring. Similar way we can do array destructuring. Array destructuring also works in the similar way, except that it extracts the values based on the index in the array. So how we can write this array destructuring? So if we want to print the value, we want to see what value is assigned. So we'll write x. So it will print 1. And if we want to see the value of y, we'll just simply write it like this. Okay, it will print 2. And if we want to have the value, if we want to see the value of z, we'll simply write it like this. And it will print 3. So in this way, we can do array destructuring. In this way, we are doing object destructuring. Now we will see what is functional parameter destructuring. In this, a function takes an object argument and then destructure that object properties into variables which can now be used within that function. So here we have a function hello. It takes an object parameter, first name and lname, and we are printing the values of those variables. And we have created one object in which we have passed the values, and then we'll pass that object to that function hello. So let's see an example how we can do functional parameter destructuring. So here's our program, functional destructuring. So we'll create a function. It takes an object parameter. So we'll pass fname. Write console.log. This function takes a function as a parameter, an object as a parameter. Okay, so we'll create one object. And pass this object to function and call the function and pass this person object as a parameter. So we'll compile this code. Then we'll run it. JS file is created, then we'll run it. See, hello ABCXYZ. So we have passed an object. It would be destructured into individual variables and we'll print that variables. Suppose we want to pass the data type also. In TypeScript, we pass the data type also. We specify the data type of variables. Okay. So if we do it like this, then this won't work because it will assign the values of these two variables, of these two properties, fname and lname, to local variables string and string. So it will give error. So in this the first and last destructor value variables get reassigned to the variable string. So the correct way to handle this functional destructuring is to define an interface and reference the interface after the destructure. So TypeScript will be able to understand that the function takes an object argument that is of type person and destructure as you would expect in ES6. Okay, so we'll see how we can do it. Create an interface. The same interface that we have created in our previous example. So we'll pass it over here that this object is of type hello ABCXYZ. Okay, so we have specified the types of these two properties also, that they both fname and lname, they both will have data type string. Now let's see what is a REST operator. Syntactically, it looks exactly the same as spread operator, but its function is the exact opposite of the spread operator. The spread operator expands individual elements, but the REST operator collects a bunch of items and puts them into an arrays or objects. In spread operator, we can spread out the values of an array or an object, but in case of REST, whatever values are there, it will collect those values and put it into array or object. So the syntax is similar as the spread operator. It has same syntax, 3 ellipses, and then the variable name. So what we are doing here is that we have an array. It contains 3 elements, 1, 2, and 3. 1 would be assigned to first number, and rest 2 and 3 would be assigned to rest of the numbers. So rest of the numbers is an array which will collect 2 values, 2 and 3. So if we print it, so first number 1 would be printed, and if we print rest of the numbers, so that it will print the array 2 and 3. And the rest operator is always the last argument of a function or of an array. In this way, we can similarly, this here we are doing rest operator on an object. Similarly, we can use this rest operator to collect items into an object. So let's see an example. Suppose we have an array. It contains 3 elements. And we are creating one more array. Array 1. Okay, So what will happen first, this first would be assigned the value 1, and this rest of element, it is an array and it will be assigned the values 2 and 3. So if we print it, so we'll get the output 1 and 2 and 3 would be in an array. So let's save it and see what would be the output. We have compiled it. Let's run it. As you can see, this first will contain the value 1 and the rest of element will contain an array. It is an array containing 2 elements. Similarly, we can also do object destructuring with rest. Okay. Suppose we have an object ABC and we have an age also 30. Okay, so what we'll do is that destructure it and using rest and rest operator. Let's compile it. Okay, compilation done. Let's run it. Okay, so age will come in this variable age, and rest of the elements will contain two elements, first name and last name. So it will be, so in this we are doing object destructuring with the help of rest operator. Now let's see what are classes in TypeScript. TypeScript is object-oriented JavaScript. It supports object-oriented programming features like classes, interface, etc. And you can say a class in terms of OOPS is a blueprint for creating objects. A class represents a real-world entity. It could be a person, it could be an employee, it could be an animal, it could be a vehicle. So basically in a class, we define a blueprint that defines the behavior and state of the object of that type. Okay, so a class basically encapsulates data for that particular object. So in a class we can have some method data, we can have some variables, and we can have some methods which operate on those variables. So it's a wrapping up of data and behavior. Let's see an example of a class. We have a class called person. It has two instance variables, first name and last name. It also has one constructor. In TypeScript, we define the constructor with the keyword constructor. A constructor is a special method that is called whenever the class is instantiated, means whenever an object of that class is created, constructor gets called. In this constructor, we are passing two variables, fname and name. These two variables are used to initialize the instance variable. Here, this keyword refers to the current object on which the method or the constructor is invoked. It also contains a methods. It has instance variable plus it has some methods which work on these instance variables. So here we have a method called getName which returns the first name and last name values. It also has one more method, intro. What it is doing, it is returning some string and it is calling getName function. So in the number one, we have class definition, properties of the class. We can define the constructor. We have the function or methods, and this refers to the current object. Now, how we create an instance of a class, how we create an object. we use the keyword new. We use the new keyword followed by the class name. So we have a object where object name equal to new class name, and if the class constructor is taking some arguments, in our case, in the case of this class example that we have seen, it takes two parameters, f name and l name. Okay, so to create an object of class person, we'll create it like this, where obj equal to new person abc comma xyz. So abc would go to first name, xyz would go to l name. In this way we can create a class. Class also follows the inheritance. Inheritance is the ability of a program to create new classes from an existing. It is an OOPS concept here, in which a child class inherits the properties and methods of its parent class. So the class that is extended to create newer class is called the parent class or superclass. And the newly created class which extends, which inherits the parent class properties and methods is called child or subclass. So in this way we can create a class and we can create a child class also. So here person is our parent class and this student is our child class. Student will be inheriting first name and L name from the parent class, and additionally it will have one more property called course, which is specific to this student class only. So we have a constructor of this student class. It takes three parameters, f name, l name, and course. Here what we are doing here, we are calling super f name and l name. So this super keyword is used to call the constructor of the immediate parent class. So the immediate parent class is person. So this will call the constructor of my person class, and it will pass two values, f name and l name. And the property, this course property of this student class would be initialized over here, this dot course equal to course. Okay, then we have a method called intro also. We can have the method with the same name in class, parent class, as well as in the child class. So the child class and parent class, they both can have the same method name. Okay, so in this what we are doing, we are returning super.intro, means we are calling the intro method of the parent class, and along with whatever string this method will return, it will be concatenated with this string. Okay, so it would be like super.intro first name, hi, my name is abc xyz and I am studying whatever course we pass in the object creation. And when we create any method or property of a class, we can specify the access modifier, means the visibility of that method or that property. So we basically have three modifiers: public, private, and protected. A public data member has universal accessibility, means that if we have declared a property or a method as public, it would be visible throughout the program. And if we declare a property or a method as private, so it would be visible, it would be accessible only within the class. It won't be visible or accessible outside the class. And protected member is accessible by the members within the same class as well as by the members of the child class also. So if we have a protected variable, so it would be visible inside that class, plus it would be visible only to the child classes. It won't be visible to non-child classes of the parent class. So let's see an example how we create a class and how we can specify the access modifiers. So let's create one class and see how different access modifiers work. So if we write private f name, data type is string, private l name. So we have a class called person1. It has two private variables, first name and last name. And we can create a constructor. We'll initialize our property name. So this is a very basic class. So let's see how we can create an object. So we'll write var object equal to new person1 and we'll pass the values. Since this first name and last name, they are private variables, we cannot change these variables outside the class. So suppose we want to do it like this. So we won't be able to do it because it is a private variable and accessible only within the class person. So if we remove this, by default it is public. And similarly, if we have protected, it will be visible inside the class as well as inside the child class. Okay, so how do we create a child class? We use the keyword extends. It has one field called course. Okay, so we can create the constructor. It takes 3 parameters: f name, l name, course. Here we'll call the super and we'll call the pass the these variables f name and l name. It will call the constructor of the immediate parent class. And to initialize course, we'll use it like this. And here we'll create the object of type student. This way we have created a child class also, and it is calling the constructor of the parent class. Similarly, we can call the method of the parent class also using super keyword. Now let's see what are interfaces. Interfaces, they are like a syntactic contract which a class or an entity must adhere. Means it will define some methods and some variables which a class which is implementing that interface has to follow it. So interface defines declares some methods which the implementing class has to provide the definition of those methods. Interface defines properties, methods, and events. It contains only the declaration of the members. It will contain only the declaration part. It won't contain the definition part. Method definition won't be there in an interface. So it is the responsibility of the deriving class, the class which is implementing that particular interface, to define the members, to provide the definition for members, to provide the initialization of the variables, of the properties, and to provide the definition of the methods. So we implement a class implements an interface using the implements keyword. So let's see how we can create an interface and how a class implements that interface. So let's see, interface is defined by the keyword interface. So we create an interface using the interface keyword. So it has two properties: first name, last name, and a method get name. We have just declared the method. We haven't defined it, and we haven't initialized any value of these f name and l name. So we'll create a class which implements this interface. So we have created an interface iPerson. It has two fields, first name and last name, and that is one method get name which returns a string value. So let's see an example how a class can implement an interface. So we'll create a class customer, use the keyword implements, I person. Now we'll provide the definition of these fields. So it will redeclare these variables fname and lname, and it has one more its own property, customer ID. So we'll create the constructor, first name, and we'll provide the definition of this method, get name. So this will defining like this, get name, string, it will return string, and it will return welcome, first name, last name with customer ID, this thing. Next, we'll create an object of this class. In this way, we are creating an object of this class, then we'll print the details. So if we run it, save it and run it, we'll get the details. So it will have customer object, welcome ABC XYZ with customer ID. And in this way, we have defined an interface and a class which is implementing that interface. We always create an object of a class. We never create an object of an interface. So here we are creating an object of the class customer, which is implementing that interface person. And it is the duty of this class customer to provide the definition and the initialization of these variables. So that's all for classes and interface. Now let's see what are arrow functions. It is a shorthand syntax for anonymous functions. Anonymous functions are those functions which does not have any name. These functions can be defined inside another function as a parameter of that function. And using arrow function, we can omit the function keyword. It is called as fat arrow. So this is the symbol for the fat arrow. And if we are using this, then we don't need to use the keyword function. The parameters are passed in the parenthesis and the function expression is enclosed within the curly braces. Okay, so let's see how we can create an arrow function. Arrow functions were introduced in ES6. They allow us to write shorter function syntax. So before this arrow function, we used to write a function like this. Welcome, hello and welcome to Angular11 tutorial. Okay, so we write it like this and we'll run it. And we call the function. So here we are defining a function hello and which is printing some values, and we'll call the function over here. Now with arrow functions, we can omit the keyword function. So we'll remove it like this. And replace it with the fat arrow symbol. Simply we just omit the keyword function keyword. And suppose this is taking some argument, so we can pass this argument over here. Suppose this is taking an argument, first name and last name, and here we'll pass the arguments values. Okay. And suppose the parameter, if this contains only one parameter, and so we can omit this thing, but this is containing two parameters, so we won't omit this parenthesis, but this is containing only one single line, so we can remove this curly braces also. And suppose it is taking only one parameter, then we can remove this thing. In this way, this is a shorthand form for writing an anonymous function. Okay, so we have constant hello equal to f name. This is taking one parameter, and this is the fat arrow symbol, and we're printing something on the screen. We are printing on the console. These arrow functions always return value by default. It will be always returning some value. So friends, that's all for today's session. So we have covered spread operator, backtick, destructuring, rest, classes, interface, and arrow functions.
Thanks friends for watching my video. If you like this video, please press like button and share it with your friends. Please write your feedback and suggestions in the comment section. And don't forget to subscribe to our channel for Kid Solutions. Bye bye, happy learning and be future ready.